Hi dear students, this particular class I want to discuss few questions related to lines and chessboard. Okay, so observe here. This is the first question. A parallelogram is cut by a set of m lines. These are m lines. A set of m lines parallel to this side and another set of n lines parallel to this side, then the number of parallelograms is equals to, right? So a parallelogram is cut by a set of m lines. All these m lines are parallel to this side and all these n lines are parallel to this side. He is asking number of parallelograms. You can observe, to get a parallelogram, suppose you want to observe this particular parallelogram. So we require this parallelogram. This parallelogram consists of two horizontal lines and two inclined lines. With these two lines, we are getting this parallelogram or not? That's why to get this parallelogram, we require two horizontal lines. Not only this particular parallelogram, for any parallelogram we require two horizontal lines and two inclined lines. These lines two required and these type of lines we required two. Now tell me, how many horizontal lines are there? Total horizontal lines is equals to m plus two horizontal lines are there. The reason is, for the parallelogram we have two lines are there and total m new lines. Total m plus 2 horizontal lines are there. From those m plus 2 horizontal lines, select any two. Similarly, how many inclined lines are there? These type of lines, how many are there? Same n plus 2 lines are there. From those n plus 2 lines, select two lines. So these horizontal lines and these vertical lines together, we are getting a parallelogram. That's why we have to multiply. So this is the answer for number of parallelograms. Now my question is, you know about a chessboard. Number of rectangles in a chessboard. How many rectangles are there in this chessboard? The number of rectangles in a chessboard. Rectangle. How many horizontal lines are there? Tell me. No, don't say 8. How many horizontal lines are there? 9 horizontal lines are there. So from those 9 horizontal lines, select two lines. And from 9 vertical lines we have 9. From those 9 vertical lines, select two lines. These two combination, you will get a rectangle. That's why the number of rectangles in a chessboard is equals to 9c2 into 9c2. Now my question is, number of squares in a chessboard. Number of squares in a chessboard we have to find out. Don't say 64 squares. Yes, here there are 64 squares. But those 64 squares are small squares. But you can observe A, B, 1, 2. This total is also a square. A, B, C, 1, 2, 3. A, B, C, 1, 2, 3 means this is also a square. But he is asking the total number of squares in a chessboard. Okay, observe here. So first of all, if you think about the 1 by 1 squares, that means we are talking about these type of squares. How many are there? These type of squares, how many are there? Okay, so that is a squares of size 1 by 1. 1 unit size squares, how many are there? Okay, observe here, no doubt, there are 8 into 8. Total we have 64 squares are there of this size. Why? Because in this row we have 8. Like these type of rows we have 8 are there. 8 into 8, 64 squares are there. Now my question is, how many these type of squares are there? Now I am asking about these squares. That means a squares of size 2 by 2. These type of squares, how many are there? This is of size 2 by 2. Yes or no? Now for these type of squares, how many? Now what to do? Observe here. So this is one square, A, B, 1, 2, right? Next, similarly, if you observe here, another one I am drawing, observe here. This is with vertical lines I am showing with BC. So this is another square. Like that, how many are there? With AB 1 square, with BC 1 square, with CD 1 square, with DE 1 square. Like that, this is the final square you will get. So how many squares we got? In this row, starting from A, we got up to G. Starting from A up to G. These type of squares, total 7 are there in this row. In this row 7 are there. But these type of rows, how many are there? These type of rows, how many are there? 7 are there. That's why squares of size 2 by 2. We have 7 into 7. That's why we have 7 squares are there. Similarly, we can proceed 3 by 3 squares. We have 6 into 6. That's why 6 square. So if you continue like that, finally you will get 8 by 8 square. That is nothing but this is a big square. There is only one, that we can write it as 1 square. That's why the number of squares in a chessboard is equal to 8 square plus 7 square plus 6 square plus and so on plus 1 square. So that is nothing but 8 into 8 plus 1 into 2 into 8 plus 1 divided by 6. Sum of the squares of the first n natural number. I hope so everyone know. Now we are getting 204 squares are there in a chessboard. Now my question is exclusively rectangles. They are rectangle but not a square. Okay, so that's why total we have 9C2 into 9C2 rectangles are there. From these rectangles, if you remove squares, then you will get exclusively rectangle. Exclusively rectangle means length and breadth are different. Right. We discussed about number of squares in a chessboard. Chessboard is a 8 by 8 grid. That's why we discussed the number of squares in a chessboard as 1 square plus a 2 square plus a 3 square plus 4 square plus and so on plus 8 square. Suppose it is a 9 by 9 grid. 1 square plus 2 square plus 3 square plus and so on up to 9 square you will get. Now this is another example. This is 1, 2, 3, 4, 5, 6. Yes, 6 by 4 grid. Now in this 6 by 4 grid, how many squares are there? That is the discussion we are going to do. Observe here. In this 6 by 4 grid, first of all tell me how many small squares are there. These type of squares, how many are there? In this row, those type of squares are there 4. But these type of rows, how many are there? 6 rows are there. That's why 6 into 4, you will get 24 small squares you will get. Now again, these type of squares, how many you will get? That is squares of size 2 by 2. These type of squares, how many you will get in this 6 by 4 grid. Now observe here, this is A, B, C, D with AB, next BC with CD, right? So you will get 3 squares in this row. Along this row we are getting 3 squares. But these type of rows, how many are there? 1, next is 2, next 3, 4, 5 are there. That's why you will get 5 into 3. Next what we will get? 4 into 2. And again next you will get 3 into 1. That is the way. So the same we can write in the summation like this. Sigma 6 minus r plus 1 into 4 minus r. That is 4 minus r plus 1 we can write. So the summation we have to run from r is equals to 1 to 4 is the least value, because it is a 6 by 4 grid. 6 by 4 grid, 4 is the least value, that's why summation we have to run 1 to 4. You can observe r is equals to 1, you will get the first one. R is equals to 2, you will get the next one. Finally r is equals to 4, you will get the last one, right? So that is the way of proceeding this 6 by 4 grid number of squares. Now I can generalize in case of m by n grid, number of squares in an m by n grid. No doubt in m by n grid the number of rectangles we can say easily mc2 into nc2, but number of squares in an m by n grid is given by summation r is equals to 1 to n. Why I am writing 1 to n? N is less than m, that means m is bigger number than m, then r is equals to 1 to n. We can write m minus r plus 1 into n minus r plus 1. This summation is the answer. So how many ways we can select two squares from this chessboard so that they are not in same row or they are not in same column? Okay, from these 64 squares you can collect any square that can be done in 64 C1 ways. Suppose you selected this particular square. This is the square you selected this square. When you selected this square, you can't select a square in this row. You can't select a square in this column also, because the two squares not in the same row, not in the same column. That's why you can't select the next square either from this row or from this column. That means total how many squares we have to remove? 8 plus 7. Total forget about the 15 squares. Now remaining how many squares are there? Total we have 49 squares are there, excluding this row and excluding this column. Total 49 are there. From those 49 squares you can select any one. That can be done in 49 C1 ways. But observe here, suppose you selected this square, next you are selecting suppose this particular square. Okay, so what we did, we selected in the first case A1 selected, next I selected a square, C3 selected. But there is a case possible. What is that case? When first you selected C3, because we are selecting from 64 any one square. From 64 we are selecting one square. Suppose I selected this square from 64. First I selected this square, that means C3 I selected. Then what to do? We have to forget about this row and forget about this column. Now from the remaining 49 squares we have to select. When we are selecting from the remaining 49, we may select this one or not. So we may select again A1. That means whatever here we got and here we got the same. That's why we have to divide it with 2 for the number of ways of selecting two squares, so that they are not in the same row, not in the same column. Now the present question is number of squares if they lie along the common diagonal. Observe here, they have to lie along the common diagonal. This is the particular case I am taking. So if we select a square along this, from these 3 squares, if you select any square, 3 squares, they lie along the common diagonal or not. So that's why that can be done in 3 ways. Now you may select along this diagonal also. Along this diagonal how many squares are there? Along this diagonal 4 squares are there. From those 4 you can select any 3. Next again you can observe along this diagonal how many squares are there? Along this diagonal we have 5 squares are there. From these 5 you can select any 3. Next you can observe here, from this diagonal, along this diagonal we have 6 squares are there along this diagonal. From these 6 squares again you can select any square. Next you can observe here, along this diagonal total 7 squares are there. From these 7 squares you can select any 3. So that's why you will get here 7C3. Now you can observe the main diagonal. This is the main diagonal. Along this how many squares are there? Along this we have total 8 squares are there. Yes or no? So total 8 squares are there. From these 8 squares you can select any 3. That can be done in 8C 3 ways. Yes? You see, above the main diagonal we got this answer. But what happens? Below the diagonal also you will get same answer or not? That's why multiply with 2. There ends the matter? No. Because we are approaching now along this diagonal. But in the similar way, another diagonal is possible like this or not? Because we can approach like this also. Yes or no? In this diagonal, along this diagonal also possible. So in this case, along this diagonal 8, from those 8 you can select 3. Again above this diagonal the same answer, below this diagonal the same answer. That's why what to do? This total answer we have to multiply with 2 to get the total number of squares. All the 3 squares lie along a diagonal. Okay, so from these 3 squares you can select 3 squares, they lie along the diagonal. From these 4 squares you can select 3, they lie along the diagonal line. Now I am finding the number of ways of selecting 2 squares so that they have common vertex, they have common side. So first of all I am finding number of ways of selecting 2 squares so that they have common vertex. Okay, observe here. This particular box, all of you observe here. This particular box, if you observe this particular box, I hope so everyone know. First of all, these type of boxes, these type of squares, how many are there? No doubt those type of squares we have 49 are there. So among those 49 squares, if you observe, if you select either this square and this square, if you select these 2 squares, we have a common vertex. At the same time, if you select this square and this square, then also we have a common vertex. That means these type of squares we have 49 are there. In each case, 2 squares are 2 possibilities are there having common vertex. This is one possibility, selection of these 2 squares having common side. These 2 possibilities having common side, right? So that's why this is one possibility, selection of these 2 squares. This is another possibility, selection of these 2 squares so that we have a common vertex. But in this square we have 2 options, 2 possibilities. But these type of squares, how many are there? 2 by 2 squares we have 49 are there. That's why in every case we have 2 chances. 49 into 2 is 98 is the answer for number of squares. Selecting 2 squares with common vertex. Now my question is number of squares with a side common. Side common. Observe here this particular case. Suppose in this row I am selecting these 2 squares. I selected these 2 squares, right? If we select these 2 squares, you can observe this side is a common or not. This is a common side. Suppose you can select these two squares also. You can select these two squares also. If you select these two squares, then also we have this side is common. So like that, how many possibilities are there? 7. Either these two AB, BC, CD, DE, like finally GH. That's why in this row we have 7 options are there. Now these type of rows, how many are there? These type of rows we have 8 are there. So 8 into 7 is equals to 56 possibilities. The number of squares having one side common. But wait, sir, why you are selecting the square along row only? Why can't you select a square like this? These are the two squares I selected. In these two squares case also we have a side common. You can observe this is the side common. If I select these two squares, we have this side common. That's why horizontally these many possibles. No doubt vertically also same possibilities you will get. That's why 8 into 7 into 2. This is the answer for number of squares. Number of squares having common vertex, number of squares having common side. So another question here, number of ways of selecting 3 squares so that they form a letter L. So they form a letter L. Observe here, suppose I selected this square, you know how many these type of squares are there. You know how many these type of squares are there. Tell me how many those type of squares are there. Those type of squares we have 49 are there. He is saying we have to select 3 squares so that they form a letter L. Suppose observe here, I am selecting these 3 squares. Next I can select these 3 squares. This is another way. We can select these 3 squares. Right? So I can select these 3 squares also. Observe here. All of you observe here. This is starting point. This is the starting point for this square. Let us feel like that. This is the starting point, and here starting point is this one is the starting point. Whereas in the other case the starting point is this one. Similarly there is another possibility is also there, that is here taking as a starting point. Now what happens here? In this square case we got 4. In this case we got 4. But these type of squares how many are there? Total these type of squares we have 49 are there. In each case we are getting 4 possibilities. Right? In each case we are getting 4 possibilities. That's why 49 into 4 is the answer for that particular question. Number of ways of selecting 3 squares so that they form a letter L. See another question here. Just it is not a chessboard now. It is x-axis and a y-axis. You can feel this one as a graph paper. You know very well. This is an origin 0, 0 point, and this point is 8, 8. A person wants to travel from 0, 0 to 8, 8 in shortest path. Okay. So then the number of different ways he can travel from 0, 0 to 8, 8. So I am saying he has to travel in the shortest path, means he is going like this. Again he is moving up like this, and again he is coming down. Unless otherwise if he is a mad fellow, then only he will go like this, going upward, again coming down, going upward, again coming down. So like that no one will travel. So he wants to move in a shortest path from 0, 0 to 8, 8. So what are the different types of path? No doubt you can observe here. So this is the way he can reach, that is the shortest path. At the same time, you can't say, sir, he can go along the diagonal. Along the diagonal where there is a path. These are the lines which are appearing. These are only the paths. He has to travel along those paths only. He can't travel along the diagonal. Where there is a road along the diagonal, that's why he has to travel along these paths only. Now that's why you can observe here like this, here vertical, horizontal, vertical, horizontal, vertical, horizontal, vertical, vertical, horizontal, like that also you can go. That's why that particular one try to catch how many horizontal paths he has to take, how many vertical paths he has to take. You can say, feel this one as a one step, horizontal step, horizontal step, horizontal step, horizontal step, horizontal, 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 again vertical step, vertical step, vertical step, vertical step, vertical step. So that's why total 8 horizontal steps are there and 8 vertical steps are there. Total 16 steps are there to travel from 0, 0 to 8, 8. So that's why he can travel in these many ways. 16 factorial by total 16 steps. Out of those 8 horizontal steps identical, 8 vertical steps they are identical. So that's why 16 factorial divided by 8 factorial into 8 factorial. This is nothing but h like that. How many times we have? 8 times are there. Similarly, vertical, 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 also we have 8 times are there. They can be arranged. These letters can be arranged in how many ways? Okay. So, what is the meaning for this? All horizontal, vertical. Otherwise, if you are writing like this, HV, 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 HV. So, what is the meaning for that? Horizontal, vertical, 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 horizontal, vertical. He is reaching to there. So that is the way of finding the number of ways to travel from 0, 0 to 8, 8 in shortest path. Now my question is, somewhere here at a point 4, 5, my house is there. My house is located at a point 4, 5. A student has to travel from 0, 0 to 8, 8. At a 0, 0, his house is located. At 4, 5, my house is located. At a point 8, 8, college is located. He has to go to 0, 0 to 8, 8. Every day while going to college, he has to wish me. Hi sir, good morning sir, like that he has to say. So that's why every day while going to the college, he has to touch my house which is located at a point 4, 5. Yes or no? Because this is 4 and this is 5. So this point is 4, that means every day he has to travel from 0, 0 to 8, 8 via through 4, 5. So how many ways he can travel? Now what to do here? First of all, he has to travel up to 4, 5. Up to 4, 5. So that's why how many horizontal steps are there? He has to take 4 horizontal steps. Next, how many vertical steps are there? He has to take 5 vertical steps. That means total how many steps? 9 steps. 9 factorial divided by 4 horizontal, that's why 4 factorial, 5 vertical. That's why he reached to my house. So after reaching to this particular point, after saying good morning, again from here he has to go to 8, 8. But to go to 8, 8, 1, 2, 3, 4 horizontal steps and vertical steps how many? 3 vertical steps are there. From there he has to travel in 4 horizontal steps and 3 vertical steps. 3 vertical steps. So that how many ways he can travel? Total 7 steps. 7 factorial divided by 4 factorial into 3 factorial. So these many ways he can travel from 0, 0 to 8, 8 through 4, 5. Okay. So next question is, so X student is there. That student, he will be afraid of me. बहुत डर लगता है उसको मेरे को देखने के बाद. That's why he want to avoid my route. He don't want to travel through my route. That means where my house is located. He don't want to travel that route. So then how many different ways? That means he has to travel from 0, 0 to 4, 8, 8 without crossing the point 4, 5. So without crossing this point 4, 5. So how many different ways he can travel? Yes. Total we can travel these many ways. 16 factorial divided by 8 factorial into 8 factorial. These are the ways travel from 4, 5. In all these ways definitely he will touch the point 4, 5. That's why subtract total number of possibilities minus through 4, 5. If you subtract 4 circles are there and 6 straight lines are there. 4 circles and 6 straight lines are there. Then he is asking maximum number of points of intersection, so that all the lines are not concurrent, not circles also, not concentric circles like that. Okay, total 4 circles and 6 straight lines are there. We have to find out the maximum number of points of intersections. We have to think in this way. If you select 2 circles, these 2 circles if you select, so how many points of intersections we are getting? This is 1 point, this is another point of intersection. That's why if you select from 4 circles any 2 circles, in this case how many points of intersections we are getting? 2. Okay, right. Now I am selecting one circle and a line. One circle selected, a line selected. Number of points of intersections, in this case also 2 only. Now I am selecting 2 straight lines. The number of points of intersection is 1. Suppose you are doing like this. So this is a circle, sir. This is another circle, sir. And the line is passing through this point, sir. And another line is also passing through this point, sir. Then what happens? You won't get the maximum number of points of intersections. What happens? You know, these points are coinciding with these points. Yes? At the same time, these 2 lines are intersecting at this point only. That's why if the same figure if you want to draw, you have to draw in this way. You know, this is the way. Because here 1 point, another point, another point, another point. Now this is another way. So this is the point of intersection. Separately it is appearing. Separately these points of intersections are appearing. Right? To get the maximum number of points of intersections, the circles and the lines has to appear in this way. That's why what to do? From 4 circles, select 2 circles. In that case, we are getting each case. We are getting 2 points of intersection. From 4 circles, we are selecting 2 circles. In each case, we are getting 2 points of intersections. Next, from 4 straight lines, select 2 straight lines. In every case, we are getting 1 point of intersection. Because these 2 straight lines are intersecting at only 1 point. Next, if you select 1 circle, total straight lines 6 are there. That's why we have to write 6 into 1. Now, from 4 circles, select 1 circle. From 6 straight lines, select 1 straight line. 4C1 into 6C1. That means this is the case. A circle and the line. So number of points of intersections is equals to 2. That's why into 2. That's why 4 circles and 6 straight lines are there. The maximum number of points of intersections is equal to 4C2 into 2 plus 6C2 into 1 plus 4C1 into 6C1 into 2. That is the answer. Okay. So these are the few discussions. Next class we are going to upload more. Okay. Bye bye.